Alright, hey everyone, good afternoon. Hope your day is going well so far. Today we're going to talk about graphing polynomials using the zeros, or another way to say zeros is x-intercepts. U now is another optimization problem, just to keep that idea fresh in your mind. So here we have a box with an open top is to be constructed from a rectangular piece of cardboard with dimensions 20 inches by 50 inches. By cutting out equal squares of side x at each corner and then folding up the sides, find the largest volume that such a box can have. Okay, so this is pretty much the same scenario that we saw last week with the volume lesson. And here I had a hint as to like what to set your window to. So y min 0, y max 3000. So the volume is going to be on the large side, and then change the scaling to 100. For x min, x max, if you do it on your TI-84 or other graphing calculator, then I would set that to like 0 to 10. That should be enough. Okay, so take another minute or so to attempt this problem, and then we will discuss the solution. Okay, so let me pause you here. Did anyone come up with a solution? You can type it in the chat or speak up. All right. All right, if not, that's okay. We'll scroll up. So if you remember from last week, right, a problem like this, the most difficult part is just setting up the equation. But after that, it is rather simple. Okay, so I still have this, this thing that we used, this sheet of paper, right? So we have x and x cut out. I know it doesn't look like congruent squares, but I just ripped it out, right? So in this scenario that they described in the problem, they would be more accurate, right? But, right, we have 50 minus 2x. Okay, so you have your, well, this is, 11 inches. So 8.5 minus 2x, right, for each side. And then for the width, it's 8.5 minus 2x. In this scenario, it's 50 minus 2x and 20 minus 2x. As for the height of the box, right, if you fold it up, right, the side of one of the squares that you cut out of the corners, that's going to be one of the heights, okay, or the height, but one of the sides of the congruent squares is the height. Okay, so it's the volume of the box is going to be x, so that's the height, times 50 minus 2x, that's the length, and then 20 minus 2x, that's the width. Okay, so this is your volume equation, and then if you graph on your calculator, you're going to find the maximum to be 4.4 comma 2030. Notice here that I included the dimensions also, but you actually don't need to do that. They just ask for the largest volume. So the answer to this question is 2030 cubic inches. All right, I'll give you a sec to copy that, and then we will move on to our topic for today. Okay, does anyone still need to copy this? All right, not then I'll move on. So let me just show you a quick overview of the rest of the lesson. So today we're going to talk about the zeros of a polynomial. Again, from the aim, right? How do we use zeros to graph polynomials? First example that we're going to do is find the zeros, or in other words, the x-intercepts of this function, x cubed minus x. And then that's going to be followed by graphing a different polynomial, x cubed plus 5x squared plus 6x. And then lastly, if we have time, I'll have you work on this problem on your own. Okay. All right. First question is find the zeros of f of x equals x cubed minus x. So first thing we're going to do is, set equal to 0. So 0 equals x cubed minus x. And from there you factor. So factor out x from this, both of these terms. So you get x times x squared minus 1. And factoring again, x squared minus 1, that can be written as x minus 1 times x plus 1. So we can see that the zeros, or in other words, the x-intercepts, are 0, 1, and negative 1. Okay, so let me make that extra clear. So again, zeros is just another way to say x-intercepts. All right, so yeah, make sure you have that in your notes, and then we'll move on to the next question. All right, anyone still need it? All right, if not, then I'll move on. All right, thank you for that response, Lou. So the next question is we're going to graph this polynomial. 4 steps. So this is the type of question that you're going to see on the homework. Just graph this polynomial following the following steps. Okay, so we have x cubed plus 5x squared plus 6x. First thing we're going to do is find the x-intercepts. Okay, so first thing I'm going to do is factor out x from these terms. Get x times x squared plus 5x plus 6. X squared plus 5x plus 6 can be factored to be x plus 3 times x plus 2. Okay, so we can see from there that the x-intercepts, or the zeros, are negative 3, negative 2, and 0. Now, just to clarify, the way you can tell that is, in this factored form, right? So if x equals 0, then the entire thing is going to be 0, right? Because it's going to be 0 times something. And same thing for negative 3, right? So if you focus on this factor, if you plug in negative 3 into that factor, then you get 0. And then the other terms, doesn't matter what they are, everything's going to multiply to 0. Okay, and then same thing for negative 2, right? If you plug in negative 2 here, you get another 0. So negative 2 plus 2 is 0, right? So that's how you would find your x-intercepts, or zeros, first factor, and then you can see what they are, right? All right, next step is finding the y-intercept. So that should be pretty easy, especially in this case, right? Plug in x equals 0. We can see that it's going to be 0 cubed plus 0 plus 0, right? It's going to be 0. So the y-intercept is at the origin, 0 comma 0. All right, next is the end behavior, which you remember from yesterday's lesson, hopefully. So this polynomial has odd degree, right? So the leading term is x cubed, right? Because the highest power is 3 in this case. It's odd degree since 3 is an odd number, and there's a positive leading coefficient since it's positive x cubed. So therefore, we can say that the end behavior is going to be as x goes to negative infinity, y goes to negative infinity, and as x goes to infinity, y goes to infinity. So in other words, it's going to have the following shape, like that, right? So it's going to go from negative infinity to positive infinity. All right, before I move on, I'll give you some time to copy what we have so far. And then the last step is to test the remaining intervals. So we're going to examine the behavior between the x-intercepts. All right. Anyone still copying this? Steps 1 to 3. All right. I'm gonna move on. All right. So step 4 is to find out what happens in between. Test the remaining intervals. So as you can see, there's this number line here, and this is a technique that you might remember from Algebra 2, and it's definitely a technique that you're going to see again in calculus. Okay. So we know what happens at -3, -2, and 0, right? Those are the zeros or the x-intercepts. But to examine what happens between these zeros, we're going to have to just draw this number line. And you can see like the zeros as gateways, so to speak, to pass from like negative to positive, right? Because 0 is neutral. It's neither positive nor negative. But outside of the zeros, it's either going to be positive or negative, right? So that if we know where it's positive and negative, then that will tell us how to draw the rest of the graph. And I know technically speaking, we actually don't have to test the ends because the ends follow the end behavior, right? So on the left, it should be negative, and on the right, it should be positive. But just for practice and to show you the idea behind this, I'll calculate it anyway. So for example, like x equals -4, right? -4 is a number to the left of -3. That's in this interval between -infinity to -3, right? So if you plug in -4 into this equation, so focus on this factored form, then you're going to get -4, right? -4 plus 3 is -1, and then -4 plus 2 is -2. All right, it actually doesn't matter what the numbers actually are, just so long as you know whether they're positive or negative, right? But it's negative, 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 right? Draw that. Yeah, so they're all negative. Okay, so it's a negative number times a negative number times a negative number, which is negative. And then for between -3 and -2, it's going to be negative, positive, negative. Okay, so that's -2.5, which is negative, -2.5 plus 3, which is positive, and then -2.5 plus 2, which is negative. And you can see the same thing here. The product is going to be positive, right? Because negative times negative is positive, and then positive times positive is positive. So there's going to be negative, negative over here, and positive over here. Okay. All right, next we have -1. That's what I'm going to test for the interval between -2 and 0. So for that, let me clear this. So it's going to be negative here, right? -1 is negative. -1 plus 3 is positive. -1 plus 2 is also positive. So this is going to be negative. Okay, and then lastly we have x equals 1. This should be positive according to the end behavior. And we'll confirm that it is. So it's positive. So +1, 1 plus 3 is +4, and then 1 plus 2 is positive. So this is going to be positive as well. Okay, so it's negative, positive, negative, and positive. Okay, so this is how the graph is going to progress from left to right. Okay, for your notes, I would copy this down as well as this diagram right here. Okay, so again, you're going to see this in calculus. The exact same technique, draw a number line and test points. And let me check the chat for questions. All right, Sam says, is this to identify critical points in calculus? Yeah, you're gonna see it in that context as well as just graphing. So like you're gonna do this exact same question, in calculus. Like they're gonna ask you to graph, but you're gonna be able to do it in a more detailed fashion because you're gonna have this idea of a derivative, which is essentially finding the slope at various points on the graph, and that will tell you how the graph changes. Yeah, but you can do it for like critical points and other things as well. Yeah.
Thank you.
Yeah. Okay, but yeah, before we get to see the graph itself, just make sure you copy this. Give you a few more seconds. All right, I'm gonna move on then. Okay, so bring this all together, right? So in summary, we have found multiple things about this graph. So first, we found the x-intercepts, -3, -2, 0. Second, we found the y-intercept. We also know the end behavior, and we also analyzed what happens in between the x-intercepts or the zeros, right? So first thing I would do, so here's a graph from Desmos. So again, the zeros are -3, -2, 0, so I will plot those first. Next, you also know the y-intercept is 0, so you actually plotted that with the x-intercept. Next, we have the end behavior. So it's as x goes to negative infinity, it'll tend towards negative infinity. As it goes to positive infinity, it'll go to positive infinity. So as we can see, it does that here. But for the sake of your graph, I would just draw like a line there. But you know that this is negative, this is positive. And then lastly, for step 4, we can draw that in. So it was negative, positive, negative, positive. Okay, so we have negative, positive, negative, positive. And again, these are between the zeros, right? So to the left of -3, right? -3 is a 0, or an x-intercept. It's negative. Between -3 and -2, it's positive. Between -2 and 0, it's negative. And then to the left, sorry, to the right of 0, it's positive again. Okay, and then I'll draw it in. Actually, it might be more helpful if I drew in like, okay, so for example, like -3, -2, 0, right? Those are your x-intercepts. Then we have negative, positive, negative, positive. And we know the end behavior. It should be negative on the left, right? So this is negative here and then positive. So it goes above the x-axis, then negative. So it dips below the x-axis and then goes through the origin, positive. Okay, so that would be what you would do, right? And of course, you can always use Desmos or your TI-84 or other graphing calculator to check your work. Okay. Does anyone still need to copy this graph? All right, if not, then I'll move on. So there's 4 minutes left. All right, for this, I don't know if we have time to work on it on our own, but let's go through it together. All right, can I get a volunteer to read this question, please?
Graph p of x equals x cubed minus 9x squared plus 20x by finding the zeros and y-intercept, and identifying the end behavior and testing the intervals between the zeros.
All right, thank you for that. So step 1 is p of x equals x times, so we're going to factor, right? So we factor out x from these 3 terms. We get x times x squared minus 9x plus 20. And then this can be factored to be x minus 4 times x minus 5. So therefore the zeros, or in other words the x-intercepts, are 0, 4, and 5. And then we have the y-intercept, which is going to be 0 again, right? For that we plug in x equals 0. So if x equals 0, then y equals 0, so it's going to be the origin. All right, next we have the end behavior. So that's So this is the same end behavior as the last example. As x goes to negative infinity, y goes to negative infinity, and as x goes to infinity, y goes to positive infinity. All right, before I move on, I'll give you some time to copy this. All right, does anyone still need the first three steps? All right, not that I'll move on. Step 4. So step 4, test the intervals in between the zeros. So we have a number line with 0, 4, and 5. Okay, and then for the interval on the left, we are going to test negative 1. All right, but as again, you can actually just see from the end behavior, it's going to be, so this should be negative and this should be positive. All right, but yeah, again, if we plug in negative 1, you'll see that it's, so this is negative, negative 1 minus 4 is negative 5, negative 1 minus 5 is negative 6. So it's negative times negative times negative, which is negative. Next we have, I'm going to test 1 for this interval between 0 and 4. So for that, I have positive 1, and then 1 minus 4 is negative 3, and then 1 minus 5 is negative 4. So we have positive times negative, which is positive. All right, next we have, I'm going to test 4.5 for this interval between 4 and 5. That's going to be positive, positive, negative. So here it's right positive 4.5. Then 4.5 minus 4 is positive 0.5. Then 4.5 minus 5 is negative 0.5. So that's going to be negative. Okay, so negative, positive, negative, positive. Last one was 6. So that's for the last interval. So that's positive, positive, positive. So yeah, 6 times 2 times 1. Okay. All right, so that's that interval. And then let me clear this. So you're going to see that the graph, so first thing I would do is plot the x-intercepts, 0, 4, and 5. And then remember it was like negative, positive, negative, positive. And you'll see that it'll be this shape. Now, of course, like you can have this local maximum here. Since this is a sketch, I don't expect you to calculate that. So for your sketch, you can also have it like here, for example, right? You don't have to have it like precisely at this maximum. Next year, when you take calculus, you'll actually do draw. You'll notice that that is a maximum using derivatives. But for now, in this pre-calc class, we will not do so. So general sketch, as long as it follows, as long as it corresponds to the information that we have dug into, then you should be good to go. Okay. All right, let me zoom out for. All right, yeah, that's step 4, and this is the graph. Okay, so let me close with announcements. Only announcement today is there's SGI 247 per usual. Draw by if you have questions, but other than that, you are free to go. If you're done copying this, I'll see you tomorrow. Take care and have a great day.
Thank you.
Thank you.
All right, you're welcome. Bye bye.
Have a nice day.
Thank you, you too.